Okay, now we're going to look at 1, 2, and 1, 6 other types of equations that involve quadratics. So for this first couple, we're looking at just we kind of saw a little bit of this with our linear equations, but we're going to have to do some factoring. So for this first example, we have 1 over x minus 4 minus 5 over x plus 2 equals 6 over x squared minus 2x minus 8. So the first thing I suggest you do is always make sure everything is factored. Okay, we can't factor x minus 4, can't factor x plus 2, but x squared minus 2x minus 8, that can factor. So a times c would be negative 8, and our factors of negative 8 that add to be negative 2 are negative 4 and 2. Since a equals 1, our factored form would be x minus 4 times x plus 2. So I'm just going to cross this out and fill that in. So when we're solving these equations, we still want to find our least common denominator. So here, our least common denominator, you're going to list any binomial that you have. So we have x minus 4, x plus 2, but we don't want to repeat anything. So we don't need to repeat the second x minus 4 and the x plus 2. So once we've found our least common denominator, we need to be careful and determine what can x not equal. Okay, because remember, we can't have 0 in our denominator. So the easiest way to do this is set your denominators equal to 0, which will happen to be your common denominator. So if we set x minus 4 not equal to 0, that tells us x cannot equal 4, and x plus 2 cannot equal 0, so x cannot equal negative 2. Okay, so those are x values we need to exclude from our domain. Okay, so now we're going to multiply every term by that least common denominator. So x minus 4 times x plus 2, x minus 4 times x plus 2, and again x minus 4 times x plus 2. And now we're just going to cancel. So on our first term, the x minus 4's cancel, and we're left with 1 times x plus 2. On our next term, the x plus 2's are going to cancel, and we're going to be left with minus 5 times x minus 4 equals, and now both our x minus 4 times x plus 2 are going to cancel, and we're simply left with 6. Now we can just distribute and solve just like we did with linear equations. So 1 times the quantity of x plus 2 is just x plus 2. Distribute the negative 5. Careful to distribute the negative with it. So we have negative 5x plus 20 equals 6. And then combine like terms. So x minus 5x is a negative 4x. And 2 plus 20 is 22 equals 6. We're going to subtract the 22. So negative 4x equals negative 16. And then divide both sides by negative 4. We get x equals 4. But now we need to check, can x equal 4? And if we look back, we said that x cannot equal 4, because if we plug that in, we get 0 in the denominator. So therefore, we have no solution. All right, looking at our second one, we have let y1 equal 3 over x plus 6 plus 1 over x minus 2, and y2 equal 4 over x squared plus 4x minus 12. Let y1 equal y2. So I'm going to rewrite this. We have 3 over x plus 6 plus 1 over x minus 2 equals 4 over, and I'm going to go ahead and factor this. Your factors of negative 12 that add to be 4 are x plus 6 times x minus 2. And then we're going to go ahead and find our least common denominator, which is going to be x plus 6 times x minus 2. And then determine what x cannot equal. So x cannot equal negative 6 or positive 2. So multiply every term by your least common denominator. I'm going to squeeze that in here. And then cancel anything out. So our x plus 6s are going to cancel. Our x minus 2s are going to cancel. And then our whole expression will cancel on the right. So now we're left with 3 times the quantity x minus 2 plus 1 times the quantity x plus 6 equals 4. So distribute, we get 3x minus 6 plus x plus 6 equals 4. Negative 6 plus 6 cancels, so 4x equals 4. Divide by 4, and x equals 1. Okay, and that's not one of our exclusions, so we know that that is our solution. Okay, the last part we're going to talk about today is polynomial equations. This is very similar to when we were looking at solving by factoring. So that's what we're going to apply. So here, first example, 3x to the 4th equals 27x squared. We always want to start with making sure we're equal to 0. So I'm going to rewrite this by subtracting that 27x squared to the other side. Okay, whenever we have two terms, we want to start off with looking for a greatest common factor, which here would be 3x squared. We divide, we're left with x squared minus 9 equals 0. Now we want to be careful here with this x squared minus 9. We can factor that further. So this is 3x squared times the quantity. We're going to do the difference of two squares. So the square root of x squared equals x, and the square root of 9 equals 3. So this is x plus 3 times x minus 3. And then you're just going to use the zero product property we talked about when we were solving quadratics. So 3x squared equals 0, x plus 3 equals 0, and x minus 3 equals 0. So if 3x squared equals 0, divide by 3, x squared equals 0, square root both sides, and x equals 0 is one solution. And then keep working. So we're going to subtract 3, so x equals negative 3, and then add 3, so x equals positive 3. And there's our 3 solutions. Okay, and looking at B, we have x cubed plus x squared equals 4x plus 4. So we're going to subtract the 4x and the 4 to the other side. So x cubed plus x squared minus 4x minus 4 equals 0. Factor by grouping. So we have x squared times the quantity x plus 1. Negative 4x minus 4, our GCF is negative 4. And we're left with x plus 1 again. So now we have the quantity of x plus 1 times the quantity x squared minus 4 equals 0. Careful that your x squared minus 4, we have a difference of two squares again. So we have the quantity x plus 1 times, so x squared minus 4 can be rewritten, x plus 2 times x minus 2. and then solve. So x plus 1 equals 0, x plus 2 equals 0, and x minus 2 equals 0, which tells us x equals -1, subtract the 2, so x equals -2, and then add the 2, so x equals +2.